Okay, so we are finally at the culmination of many days of work and many different mini lessons. So, this is the day we get to talk about matrix equations. And I want to start by just kind of walking you through how this process works. Okay, so you've got a matrix A and a matrix B here, and X is a matrix we don't know. So we are literally trying to figure out what matrix could we multiply by one matrix A to get matrix B. All right, so that's what we're trying to do. We're solving a matrix equation, just like it looks down here. All right, and so in this process, what we're going to need to do is find an inverse matrix. Okay, so what I'm trying to tell you is this: there is no such thing as division in matrices. It is only a multiply by the inverse type thing. All right, so let's take a look over here at a basic equation like algebra 1. Okay, if we wanted to get rid of this 1/2 in front of this x, yeah, we could divide, but what's a maybe more efficient way that would make more sense? How about multiply by the reciprocal of 1/2, which is 2? You don't always have to think about it in terms of division. So this little thing that we did right here is basically the same thing we're going to do in the matrix world. Okay, we've got to use an inverse of the matrix. We can't just divide. There's a couple things we need to talk about, and one of those would be why this works out. Why is A times A inverse the way out of this situation over here? How does that undo matrix A? Well, it's just like any other inverse that you can think of. It's the opposite. It does the opposite thing, just like 1/2 multiplied by 2 over 1. It gets us out of the problem of having a coefficient on x that's not 1, because they kind of cancel each other out in a sense, is what I'm trying to say. It leaves us with a 1 coefficient on x, and then we're free to say we know what the answer to that equation is. So that's what A times A inverse does for you with matrices. All right, and let's say you had two matrices that you multiplied together. What you would do is you would get a matrix. Oh, that's that's supposed to be a. I do not have this right. Here we go. I looked at that like, what is that? I do not have that right. Okay, so this is what you call the identity matrix. The reason why is because there are ones on that diagonal, that primary diagonal from left to right. That's called the identity matrix. If you multiply a matrix by its inverse, you will get an identity matrix. I don't think it is worth our time to worry about the fact, does that happen over here? When we're doing these problems, we're literally just going to go from this step to this step. We're just going to assume we understand that's what's happening here. We do not have to verify that the identity matrix is what we're going to get on the left hand side. That's just stuff we don't need to worry about. Okay, so here's what I want you to do. Go ahead and write down these examples if you hadn't already. So pause the video if you have to. All right, so what we want to do is solve this thing for x. There's a matrix that I can multiply A times that matrix and get matrix B, but I don't know what it is. But if I find the inverse of A and multiply it by B, in that order, we have to do the inverse first, the inverse first, the inverse first, okay? Inverse first times matrix B, or else it won't work out. Sometimes it will, sometimes it won't. In this case, it will not. And then we will get the matrix that we're looking for. All right, so first thing we got to do is find A inverse. And it's been a while since we did that. So remember, here's what that process looks like. We found the determinant, and then we did a little change on elements D and A and changed the signs on B and C. We didn't switch their spots, we just changed their signs. All right, I want to find the inverse of matrix A first, this first one. So let's find the determinant. Ready? So that's 6 minus -5. Looks like an 11 to me. Oh, no, Ms. Brown. That's a 0. Shame on me. I almost gave somebody a brownie point, even virtually. Goodness gracious. All right, so 6 minus 0 is 6. So that's 1/6 for your scalar on this matrix. 1 and 6 will switch spots. And then -5 and 0 change signs. Now, 0, it doesn't really matter what sign's on it. So no worries there. All right, your inverse for A. Let's multiply that scalar through. So it's going to be 1/6, 5/6, 0, and 1. Alrighty, so our inverse goes first. Then we're going to multiply that by matrix B. And from here, we're just going to do matrix multiplication. All right, so that's what we just did in the last lesson. So we need to figure out what the dimensions of the answer matrix are going to be. So remember what we do is we figure out the matrices dimensions. The first one is a 2 by 2. And this is a 2 by 1. These do indeed match, so our answer's dimensions will be a 2 by 1. So 2 rows and 1 column. Alrighty, so row 1 gets multiplied by column 1. -40 times 1/6. I'm just going to leave that as -40/6 and hope for the best here in a second. 5/6 times 2. Again, the top number multiplied by that numerator. The numerators, so that'd be 10/6. Okay, the denominator is just going to stay there because this denominator is technically 1. All right, row 2 times column 1. 0 times 40 is 0. Add to that 1 times 2. Oh, I can do that one in my head for sure. Now look what happens up here on this top row. You've got -40 plus 10. That's -30. And it's over 6. Ooh, that's just -5. So I encourage you not to whip out that calculator so quickly. You probably can do it in your head. Well, there is your matrix that multiplied that first matrix A times this matrix would give you the -40/2 matrix B. Wasn't that bad. All right, so let's do another one. So the first thing we got to do is find the inverse. Find the inverse of the first matrix. We call it matrix A. Well, I thought I changed colors. It just has to wig out on me to change colors, I guess. Come on.